Okay, in this particular lesson, what we're going to look at is adding and subtracting rational expressions, in this case, that have different denominators. The key idea for adding and subtracting any type of fractions or rational expressions is that in order to add or subtract rational expressions, you must have a common denominator. And in this case, since we're not going to have common denominators, we're going to have to create them. For example, if we were to, in previous math courses, add something like 3/4 plus 5/6, you would ask yourself, what do the denominators of 4 and 6 go into? And they can be both made into 12ths. And we'd multiply our first fraction, because 4 goes into 12 3 times, we multiply that by 3, we'd be left with 9/12, and 6 goes into 12 twice, it'd be 9/12 plus 10/12, and that would leave us with a numerator of 19 over 12, and that would be how we would do that. In the case of rational expressions, probably what we're going to notice is it's often more difficult to determine what our common denominator is going to be and then to simplify. So one thing that we're going to look at is factoring completely. So in the case of 3 over 4, we could have made it 3 over 2 times 2 plus 5 over 2 times 3, and you can notice that we could make both of our denominators 2 times 2 times 3 if we just decided to multiply the first fraction by 3 and our second fraction by 2. It's the same basic scenario, but you can see here when we factor that in each denominator we have a 2, a 2, and a 3, and a 2, and a 2, and a 3. We'd get the same result, but it'll be easier in rational expressions if we factor completely, and that gets me to the first step. The first step of simplifying with different denominators is to factor the denominators completely, and before we start simplifying, state any of our non-permissible values. And the third step, and probably the most difficult one, is to make sure that after we've done that is to write each expression with a common denominator. Because in order to add or subtract any type of rational expressions, we have to have a common denominator. Finally, what this is going to do is require us to multiply some expressions by some sort of common factor. Okay, you might have to multiply both or one or multiple expressions by a common factor to do this. Fourthly, much like we did in the previous lesson, next all you need to do is add or subtract the numerators over the common denominator, and finally what you're going to need to do is simplify completely. And what this may do is require factoring, which we have looked at in previous lessons as far as how to factor, so I'll do those parts rather quickly. We're going to look at 3 different examples in this case. In this particular case, what we'll want to do first of all is probably rewrite this just so it's easier to identify as 3a over ab minus 5, maybe over 1 might be easier, because what some students do is don't realize that a whole number or a whole expression has a denominator if you'd like to make it a rational expression, and that's plus 4 over, and a squared is the same as a times a. In this particular case, dealing with our non-permissible values, the factors of a has a non-permissible value of a cannot equal 0, and there's also a factor in the first denominator of b, so that leaves us with b can also not equal 0. In this case, you want to ask yourself again, some have stated lowest common denominator as how to approach this. It doesn't really matter what you call it, as long as you realize that our common denominator, we can make a denominator of 2 a's and a b, or in other words, a squared b. In order to do that, what we'd have to do, and I'll use different colors in each case, is multiply each expression is going to need to be multiplied by its missing factors. So our first expression here is going to have to be multiplied by, and maybe I'll use a dot instead, just so you're not confusing anything with that. It has to be multiplied by a because we need a pair of a's. Our second particular rational expression needs all the parts of your common denominator, so times a times b, and our last rational expression is missing a b, so let's multiply it by b. So in this particular case, if we look at all of our numerators, our first numerator is 3a squared, second numerator is minus 5a squared b, and third numerator is plus 4b, and that's each of those expressions is over a common denominator now of a squared b. This particular step, if you'd like to skip it, you could, because what we know is once we have a common denominator, we can add or subtract the numerators over that common denominator. And in this particular case, since there's no greatest common factor in our numerator, there's no common factors in our numerator or our denominator that we can cancel out. Some are probably tempted to get rid of these a squared b's, but you're not allowed to do that because this numerator is a trinomial, so the entire trinomial factor has to be identical in order to do that. So that's a common mistake. There's our first example. In our next example, first thing we can do is factor our first denominator. You'll notice that you're making a mistake if you start simplifying and get some sort of cubic function, because this unit we can't do any cubes. So if you're getting to that point, you've probably not factored completely or simplified or gotten your lowest common denominator. In this particular case, what we can do is, and it's the only factorable part, is factor our first denominator to a difference of squares of x plus 2 and x minus 2. And that is then added to x minus 2 over x plus 2. In this particular case, we're dealing with two different non-permissible values before we start simplifying. One of our non-permissible values is that x cannot equal negative 2, and our other non-permissible value is that x cannot equal 2. Now we can start making our common denominators before we add, and what you'll notice is that our common denominator that we can create in both cases they both already have an x plus 2, and we can give them both an x minus 2 factor. Our first expression already has an x minus 2 factor, so we already have a common denominator of x plus 2, x minus 2 in our first expression, which means that all we're going to need to do is our second expression, we need to also introduce another factor of x minus 2 to give us a common denominator. So in this particular case, what we have is x squared minus 20 plus x minus 2 times x minus 2 all over a common denominator. Now you could actually, we have a common denominator, so I'm just putting it all over the common denominator. The next thing you'd want to do is in your numerator, we're going to want to simplify. So before we can think about factoring our numerator, we're going to have to expand it, simplify, and then maybe try and factor again. So what we have in our numerator is x squared minus 20 plus, and in this particular case, it'll be x squared minus 4x plus 4 all over a common denominator of x plus 2 and x minus 2. And what we can do now is simplify our numerator, collect our like terms, and that would be 2x squared minus 4x minus 16 all over, and I'll just put CD for common denominator. If we factor our numerator some more, we have a greatest common factor of 2, so that's going to be x squared minus 2x minus 8 all over our common denominator. And that trinomial can be factored to x minus 4 and x plus 2. And what you'll see is now over our common denominator of x plus 2, x minus 2, we do in this particular case have two common binomial factors of x plus 2. So our simplest form in this particular case is 2 times x minus 4 all over a denominator of x minus 2. That is our simplest form. So you can see where this takes a lot of work. In our next one, one thing we're going to need to do is, before we start stating our non-permissible values, is to factor our denominators. So our first denominator could be factored to, if we factor a greatest common factor of 2 out, we'll be left with x squared plus 9x plus 8. And that x squared plus 9x plus 8 can actually be factored to x plus 1 and x plus 8, so maybe I'll replace that right away. So it's going to be 2 times x plus 1 times x plus 8 if we like to completely factor that. In our second rational expression, our denominator, we could use the decomposition method, which you could look at previous lessons for in Chapter 4, Section 2, so 4.2 lessons. I'm just going to do guess and check as far as factoring this. So our factors will be these, because our middle term will be 2x minus 3x, and that leaves us with negative x as our middle term, and our first and last terms are correct as well. All right, so in this particular case, what we'll first look at is the non-permissible values. We have three unique factors with variables in them. So from each of these particular factors, we're going to have the x cannot equal -1 as one of our non-permissible values, x cannot equal -8 as our second non-permissible value, and also x cannot equal 3/2 as our third non-permissible value. Alright, so now we can start creating our common denominator. And our common denominator in this particular case, each of these rational expressions already have an x plus 1, but that's the only common part at the moment that they have. So our common denominator is going to be, maybe I'll just write it here, your common denominator, we're going to need a 2 in each one from that first 2. We're going to need an x plus 1 in each one. We're going to need an x plus 8 in each one. And we're going to need a 2x minus 3 in each one. So anything that seems to be missing from each factor or from each rational expression is going to have to be added. So in this, if we compare this first denominator to what our common denominator is going to be, you'll see a 2x minus 3 is missing. So I multiply that by 2x minus 3. In our second rational expression, you'll see that there's actually 2 parts missing. The number 2 is missing as far as a unique factor, so we'll have to times it by 2. And the other factor that's missing is an x plus 8. So we'll have to multiply the numerator and denominator by 2 and x plus 8. We'll have to be careful about how we multiply that. Okay, so the next step is to start kind of simplifying. Our first numerator right here, if I wanted to, first of all, expand it, I would get 2x squared minus 3x. Okay, and our second numerator is going to be minus, and we're going to have to take the opposite of this entire numerator. So let's start multiplying it very slowly. So you have 2 times x minus 2 times x plus 8. One thing you need to do, because you have a monomial with 2 binomial factors, you need to choose which 2 of those. Doesn't matter which 2, but you need to multiply 2 of those factors first. And I'll just put over, in this particular case, so we'll get to that step in a second, I'll just put over our common denominator. And we know what that common denominator is and is going to be. But what I mean, what I previously said, is choose a pair of factors here to multiply. I'm going to multiply those guys. So x minus 2 and x plus 8. If I do that, what I'm going to be left with, and maybe I'll just draw a line here in order to represent that, is, so I have the 2x squared minus 3x, then I have the minus 2, and that's going to be, when I multiply that, it's going to be x squared plus 6x minus 16, and that's all over our common denominator, which I could write, but I'm not going to at the moment. Last thing to do is to expand or distribute that -2. So our numerator is going to be 2x squared minus 3x, and then as I expand it, it'll be minus 2x squared minus 12x plus 32 all over our common denominator. As I collect like terms in my numerator, the 2x squareds cancel out, so I'm left with a total of negative 15x plus 32 in my numerator. And that numerator cannot be factored. So you'll notice that there's no common factors in my numerator and my denominator. So it's all over my common denominator, which is this right here. So my simplest form is negative 15x plus 32 all over 2 times x plus 1 times x plus 8 times 2x minus 3. And that is the simplest form, since neither anything in our numerator or denominator can be factored any further.